Now let's talk about carbon dioxide levels and temperature. The relationship between those two things is really important. First of all, climate.nasa.gov gives us a lot of really great information about temperature and carbon dioxide levels. As you see here on the left, we see that temperature has been going up steadily for the last approximately 100 years. A lot of that can be attributed to climate change. And so what we are focused on as far as this graph is concerned is the average between 1951 and 1980. That's what all the other temperatures are compared to. So when we talk about the temperature is increasing, that's the average that we're looking at. Let's zoom in on part of this graph, the last 20 years. And what we see here is that temperature on Earth has been increasing so much that it's almost 1 degree Celsius over that average. And over the last 20 years, it's increased over half a degree Celsius. Another way of looking at this temperature change on Earth is through a time-lapse image of the relative increase in temperature on different parts of Earth. And as you see the years increasing in the upper right-hand corner, we see that not everyone on Earth is experiencing the same temperature rise. Specifically, what we can see is that in the northern latitudes near the North Pole up here, that the temperature difference is extremely different than everywhere else on Earth. And you should also see this difference between land and ocean. And so as we get closer to present day, what we see is that temperature anomaly or temperature difference by the poles gets to be about 4 or 5 degrees different than in that average range of 1951 to 1980. And there's that difference right there becoming really obvious. This is the world we now find ourselves in, where we see overall throughout the entire globe, there is a massive temperature difference. Does anyone have any ideas as to why there's a big difference in temperature in the northern latitudes, specifically near the North Pole?
Well, part of the reason is because there's a lot of ice in the North Pole, and because of the albedo, it's reflecting off the ice and melting the ice, and then there's more water that can absorb the heat and the light, and so it's warming up at a much faster rate up there.
Excellent, thank you. And as we see, there are pockets of ocean that are still at average temperatures, and water holds on to heat a lot better than land does. And so that's something else to consider when looking at these maps. Let's talk about carbon dioxide, because that's the other half of this picture. As of last month, carbon dioxide levels worldwide at Mauna Loa Observatory in Hawaii, which is the main observatory used, we're at 417 parts per million. And what we see, the general trend happening is that carbon dioxide levels are doing what?
Carbon dioxide levels are rising.
Excellent. And what is the other trend that's happening on an annual basis? What do you see happening here?
It fluctuates.
Excellent. Does anyone know why that fluctuation happens over the course of a year?
It's because of like the growing of plants and such. Because the spring they like bloom more and they're growing, so they're getting more carbon dioxide out of the air and putting more oxygen into the air. But then during the winter, the carbon dioxide levels start increasing again because there isn't everything's covered in snow. Everything is toned down for the winter because it's cold and stuff.
Excellent. A common question at this point is like, but this is for all of Earth. The northern hemisphere has so much more land area that it outweighs the effects in the southern hemisphere. As we're entering summer now, the southern hemisphere is entering winter, but because there's so much more land, there's so many more plants that are taking up carbon dioxide, that's what accounts for this effect, this bouncing up and down over the course of the year. This is accounting for that effect and is taking a running average. So this black line is more reflective of overall carbon dioxide levels, not taking into account what's called seasonal variation. So we see that seasonal variation over here on the bigger graph. That's giving us over 60 years of data. And then the black line again is giving us that rolling average that helps us understand a little bit better what's happening over longer periods of time. And finally, if we compare what's happening with carbon dioxide levels with temperature, then we see that both are in fact increasing over time over the same time period. There are little variations, but ultimately the trend is up. What are your predictions for global levels of carbon dioxide and temperature? I guess in your lifetime, what do you think? What are your predictions?
I feel that technology advancing, there's going to be people trying to prevent the advancement of CO2, but at the same time, I feel like we've made it so far with it increasing that it's going to be hard to completely prevent and to reverse it.
Yeah, I agree with Alanis. I think that it may eventually go down, but we're going to have to put in a lot of work for it to be able to go down because it's not going to happen immediately.
Especially with like the technological advancements, maybe it'll be easier to predict and find better solutions that can be beneficial to decreasing the CO2 in the atmosphere.
And what do you think about how coronavirus might have an effect on carbon dioxide?
I mean, people are still, driving. It's not going to have that much of a change because we've always been very consistent with having such a high level of carbon dioxide in the air. And just because we're being quarantined doesn't mean that's going to be immediate change.
Excellent, thank you. And then finally, what would happen to global temperatures if carbon dioxide levels dropped to below 350 parts per million tomorrow?
Even if we manage to drop CO2 levels to below, what was it, 350 CC, by tomorrow, the temperature, like the overall temperature of the Earth would continue to increase because it's got like all that momentum behind it. Like it's been going up for so long, even if we decreased all the CO2, like right now, the temperature would continue to increase for years to come.
Wonderful, thank you so much. So hopefully this gives you some more information about the link between carbon dioxide levels and temperatures on Earth.